talking about polynomial identities today. An identity simply is an equation where both sides of your equation are actually equal to each other. So all values are true. So if I have an identity and I plug in a 5 on each side, it comes out to be the same. So any number I plug in, it's going to give me a true equation. Taking a look at our first identity here. We have x squared minus y squared equals x minus y times x plus y. So they want us to test it using 10 for x and 3 for y. So we're just going to plug in 10 for our x, 3 for our y. We're going to see if both sides of that equal sign are going to end up being equal. So 10 squared minus 3 squared. We're going to see if that equals 10 minus 3 times 10 plus 3. So let's figure out the left side of our equal sign. What is 10 squared? 100. 3 squared. So 100 minus 9, 91. The left side gave us a 91. We're going to see if the right side gives us the same thing. So 10 minus 3 gives me 7. 10 plus 3 gives us a 13. So 7 times 13 is 91. And that gets a check because 91 does in fact equal 91. So part B, they want us to prove this identity by manipulating the right side of the equation. And I'm going to put a little star here because with identities, this is the step you're going to be doing most often, is they want you to prove the identity to be true or false. So x squared minus y squared equals x minus y times x plus y. We're trying to prove it to be true. They told us to manipulate the right side of the equal sign. So what could we actually do to the right side there? Multiply them out. So distribute your x. And that's going to give us an x squared plus xy. Distribute our negative y. And that gives me a negative xy minus y squared. And then what happens with our xy's? Cancel. So we're left with x squared minus y squared, which is actually what we had on the left side. So that identity is true. Now don't go assuming that every single time they tell you to prove this identity to be true, it's actually going to be true. It doesn't always work out that way, so please don't just go under that assumption. You got to actually do the work for it. So now that we know it's true, we're going to use it in order to simplify some numbers. So this is something that you would use if you don't have a calculator or are not allowed to use a calculator. This is a strategy that we can use. So again, here's our identity. Which really, what is that identity actually doing? Just factored it, didn't it? Isn't this just our dots factoring? 2 perfect squares subtracted factors into that. That's all that identity is. It's just the factoring rule. So we're going to plug 50 in for x. And 49 is our y because the 50 goes first, the 49 went second. So our identity is saying it should be 50 minus 49 times 50 plus 49. It's going to give us our answer. So 50 minus 49, 1. 50 plus 49, 99. So we get 99. So let's check it in our calculator. In your calculator, go ahead and type in 50 squared minus 49 squared. And we get 99. So it ends up working out. We're going to skip over part B for that one. So again, you just got to prove the identity to be true. Do some manipulation so that both sides match. Sometimes you've got to plug a number in. So if we take a look at our second one, they want us to prove the identity a plus b squared equals a squared plus 2ab plus b squared. And then they want us to use it to evaluate 35 squared. So a plus b squared really is a plus b times a plus b So this time we're going to multiply out the left side to see if it matches the right side. So a times a, and then a times b times a, and then b times b. Combine your middle terms, and do we get one that matches? Yes. So that identity actually is true. And again, don't just assume it is, because sometimes they'll give you one where it's simply trying to say that a plus b squared equals a squared plus b squared, because that's a common mistake that students make. And it wouldn't actually be true for that one. Got to have that middle term of that 2ab in there. That's what makes the identity true. So they want us to use it to evaluate 35 squared. So again, this is a technique you would use if you didn't have a calculator to use. Like, for example, on your PSATs, I know there was a section where you weren't allowed to use your calculators. So 35, we could break apart into 30s plus 5. So I still have the same value. I still have a value of 35. I've just broken it up into two numbers that'll be a little easier for me to manipulate. So using my identity, that would be 30 squared plus 2 times 30 times 5 plus 5 squared. So again, I'm just plugging my 30 and my 5 into my identity. So 30 squared. You guys do that in your head? 900. Because 3 squared is 9, and then you would just have 2 zeros because it's squared. And then 2 times 5 is 10 times the 30 makes that 300. And then 5 squared, 25. So now 900 plus 300, and then plus 25. 1225. So let's check it in your calculator. Just type in 35 squared. Let's see if we get 1225. Yep. There we go. All right, third example. There is also an identity for the difference of perfect cubes, and it's given there. We went through that on day 1. Prove this identity by expanding the product on the right-hand side of the equation. So I'll copy down our identity first. So you go ahead, take a minute, expand out that right side by multiplying, so do your distribution, and then combine your like terms. See what we get. So did we get that it worked out? Yeah, good job. It should, because your x squared y and your xy squareds end up canceling out. You had 1 plus, 1 minus for each of those. So now they want us to use this identity to find the value of 10 cubed minus 9 cubed. Without the use of your calculator, show the steps in your calculation and then verify with your calculator. All right, so 10 cubed minus 9 cubed. Again, I am just following my little formula up there. 10 is my x, 9 is my y. So 10 minus 9, then 10 squared plus 10 times 9 plus 9 squared. So again, let's try to do this without our calculators. That first part's pretty easy. 10 minus 9, 1. So then inside the other one, 10 squared, 100. 10 times 9, 90, and then 9 squared, 81. So 100 plus 90, 190, plus 81, 271, and then times the 1 would still be 271. So then go ahead, type that in your calculator, 10 cubed minus 9 cubed. Let's see what we get. 271. So it works out. So all those factoring things we've been doing also work with